Hello, my name is Pranav, and this is my Physics 2212 Lab 1 charge tapes. The purpose of this lab was to create a charge tape. Once these charge tapes are created, we were able to determine the charge and polarity of the tapes and create two models to model their behavior. One modeled both tapes as an individual point charge, and the other used two line charges. We made a couple assumptions to make these models work. The first is that there was no air resistance present. The second was that the tapes had the same charge, and the third was that the charge was evenly distributed among the tape. We used the three concepts on the left, Newton's second law, Coulomb's law, and the formula for gravity in order to determine the polarity and charge of the tapes. The results were that the point model charge was 1.31 e to the negative 8 coulombs, and that there was a deficiency of 8.16 E10 electrons on the tape. And using the line model, we got a different charge of 6.20 e to the negative 9 coulombs. There were three steps of the experiment. The first was U-tape formation. So this was done by putting one tape on the table and putting another tape on top of it, making a handle and pulling it off really quickly, which caused some charges to deposit onto the base tape. The second was to determine the polarity of the tape in question. So the way this was done was using my hand and a plastic pen, which were rubbed in my hair to make them negative, and placing them near the tape. Since the tape was attracted, we knew that the tape was likely positive. Then the third part of the experiment was to float the tape. So we took another U-tape and placed it under another U-tape that was suspended on two books, and we measured the distance from which the upper tape would start to float, and this came out to about 2.8 centimeters apart. And the system in this case is tape B, the top tape, and as you can see in this free body diagram, the electric force is pulling it up and the force of gravity is pulling it down. The measurements of the tape in question are 20 centimeters long and 1.9 centimeters in width, and the weight was about 0.2 grams. The first model uses the point charge assumption. Each of the tapes was modeled by one of the balls, and the red force represents the electric force that pushes them apart, and the gravity is represented by the blue arrow. So we assumed that since there was no change in momentum, both of the forces in this case were equal to each other. So using the script on the left, we calculated the force of gravity as the mass of the tape times the g constant, and we set the electrical force equal to its magnitude. Using the value for the electrical force magnitude, we then calculated the charge Q using Coulomb's law. Then we determined the amount of atoms that were in the total tape by taking the length and width and dividing them by the average square area of an atom. And then we found the ratio of electrons to atoms. So using this information, we found the magnitude of the charge on the tape can be estimated as 1.31 to the negative 8 coulombs. The magnitude of the electrical force and the gravitational force were the same at 1.962 e to the negative 3 newtons. There was a deficit of 8.16 to the 10 times 10 to the 10th power electrons, and the ratio of deficient electrons to atoms was 2.14 e to the negative 7. The second model used line charges, where we modeled the tapes as a set of DQs, as you can see here, that were repelling from the bottom tape and summed up into this larger white force. And so to do this in the code, we created a method that would that defined an E field, and this E field was used to find the interactions between each of the individual DQs. And so using these numbers, we were able to calculate the magnitude of the electric force and the magnitude of the gravitational force, which are 4.1 e to the negative 4 newtons for the electric force and 1.962 e to the negative 3 newtons for the gravitational force. Also, I used the magnitude of the electric force to solve for Q, the charge on one tape, and this was found to be 6.19 e to the negative 9th coulombs, which is different than what we found in part 1. One of the questions is what would happen if the polarity of electrons or neutrons were reversed. So what would happen here, due to charge symmetry, there would be actually no difference in the behavior, but my hand would be positive and the tape would be negative. So the actual sign of the force would be different, but there would be no difference in behavior. Also, the two models, the point charge model and the line charge model, had two different values for Q. So the reasoning for this is likely because in the point charge model, we assume there's only one distance value, the minimum distance value, whereas in the actual real-life line of tape, there'd be multiple different distances between all the different charge sections of the tape that are interacting with each other. So because of this larger distance, there would be a smaller value for the electrical force in this case. The line charge model is likely more realistic, as the point charge model makes a lot more simplification. So one of the sources of error could have been that touching the tape could have discharged some charge from my negative hand to the positive tape, and this would reduce the overall charge of the tape itself. Also, the interactions within the one section of tape between the negative charge on the single tape were ignored. Interactions with air were also ignored. So these all could have been sources of error that would cause